In exercise number 8, you are testing items off a production line, and your benchmark proportion of defectives is 3%. So 3 out of every 100 are going to have a defect and will be rejected. Let's suppose that the true defective rate is indeed 3%. From a sample of 100, what is the probability that the sample has 5 or more defectives? Well, you already know how this is going to pan out. The probability that x is greater than or equal to 5, the number that are defective are greater than or equal to 5, is equal to 1 minus the binomial distribution of 4 or less given 100 samples and a 3% chance of success on each one. Now, success in this case is actually a failure. So success is, got to be careful how you word it there. I'm going to go ahead and go to formulas and click show formulas so that you can see that we set up 1 minus binom dist of 4 given 100 samples, or a sample of size 100, n equals 100, and a probability of success, entre comillas, and true for the cumulative. And by doing that, we get a probability of 0.182 is the probability of seeing more than 5 or more. The second part of the question asks, from a sample of 300, so a bigger sample, what is the probability that the sample has 15 or more defectives? This is interesting. Okay, so before we had an 18% chance of seeing 5 or more. Now we triple the sample size and we triple the expectation of 5 per 100. But interestingly enough, because there's only 3%, 3% is the proportion we're dealing with, the result of the probability that x is greater than or equal to 15 is not just 3 times the probability of what we had in the previous answer. You'll notice that it's actually almost 4%. So it dropped from 18 down to 4%. And then if we go to the bottom one there, from a sample of 1,000, what's the probability that a sample has 50 times more? So you'll notice that part C relates to part A by a factor of 10. Okay, so the sample is 10 times larger, and the expectation of 5 or more defectives now is the same as 50 or more defectives, a factor of 10. But the probability of seeing that many defectives is very low. It's hundredths of a percent low. So, in each case, you're calculating the chance of 5% or more defectives in the sample when we know the true underlying rate is 3%. So in each case, we're calculating the chance of an unlucky result. Chance of an unlucky result gets smaller as the sample size gets larger. This is not surprising. From a large sample of items, we expect the proportion of defectives to be closer to the true underlying level of 3%. So it becomes less probable that we will deviate from this 3% level.